Good morning, my students. Today we are going to take Unit 2 in Geometry, which consists of Lesson 1, Congruency, and Lesson 2, Symmetrical Figures and Lines of Symmetry. Let's start. The first lesson here is congruency, okay? So what's the meaning of congruency? Congruency in geometry, it's identical in form, must be identical, but under two conditions. Two polygons are congruent if, number one, or the first condition, their corresponding sides are equal in length and their corresponding angles are equal in measure. Okay, so I underlined here word sides and equal in length and angles are equal in measure. Okay, I make a small trip here, SLAM. The four letters here represent sides equal in length and angles equal in measure. Okay, so again, the two polygons are congruent if their corresponding sides are equal in length and their corresponding angles are equal in measure. Okay, let's start by the first example. If the polygon ABCD congruent, this is the sign of congruent, okay, congruent to the polygon XYZL. Here are the two polygons, okay, ABCD congruent to XYZL. Okay, number one, if AB equal to XY, this is the side, and the second side here BC equal to YZ. Okay, the third side is CD equal to ZL and DA equal to LX. Okay, so the sides are equal. Number two, we are going to represent the angles. Measure of angle A. Okay, the angle is here. Measure of angle A equal measure of angle X. And measure of angle B equal measure of angle Y, and measure of angle C equal measure of angle Z, and measure of angle D equal measure of angle L. That's why the two polygons are congruent. A, B, C, D congruent to X, Y, Z, L. Don't forget the sign of congruency, okay? Then take care of something. Okay, the equality of corresponding sides of two polygons, if I have the two sides or the two corresponding sides are equal, it's not enough to be congruent, okay? But the equality of corresponding angles is needed as well. So we must get the angles also. Okay, page 2, I have here three cases or special cases. Number one, the square, okay? Number two, the rectangle. Number three, the triangle. Let's start by the square, okay? Or the first case. Two squares are congruent if the side lengths of one of them equal the side of the other. If only one side equal to the other, it will be congruent. Why? Because the square, all sides are equal. If you get only one side, you will get the other sides, okay? So the square ABCD congruent to the square OPQR, okay? Because the square, all sides are equal. So the square are congruent if the side lengths of one of them equal the side length of the other. This is the first case. What about the second case, the rectangle? Two rectangles are congruent if the two dimensions, what's the meaning of word dimensions? The length here and the width, okay? Because the sides of rectangle is called length and width. If the two dimensions of one of them equal the two dimensions of the other, okay? I have here the two rectangles, L, M, N, O, congruent, watch the sign again here of congruency, to the rectangle FGHE, FGHE. So if LM here, the length, equal to FG, and MN, the width, equal to GH. Okay, this is the second case. The third case here, the triangle. The equality of corresponding sides of two triangles, if the sides are equal, is enough to be congruent. It's enough to be congruent. Okay? Why? This is because the equality of corresponding sides leads, okay, to get the equality of corresponding angles. Okay? So, if I have here A, B, C congruent to X, Y, Z. Okay? I have here A, B, C congruent to triangle X, Y, Z. We can solve it from the letters. Okay? So skip now the figures and let's start to solve it by the letters. Okay? It's a small trick also. If I have AB, I start by the first letter and end with the second one. Okay? And AB equal to XY, the first one and the second one. The first one and the second one. So AB, it's equal to XY. What about BC? BC equal to YZ. Okay, the middle and the last. The middle and the last. Here it is. BC equal to YZ. What about CA? If I will move from the last one to the first one. CA equal to ZX. Okay, ZX. The last one and the first one. Okay, you have to watch your letter. Okay, so again, I have here the three cases. The first one is the square. Okay, the second one is the rectangle. The third one is the triangle. The square, if you get only one side, okay, equal to the other, so it's congruent. Okay, because if the side lengths of one of them equal the side lengths of the other. What about the rectangle? If the two dimensions of one of them equal the two dimensions of the other. What about the triangle? I told you the equality of corresponding sides of two triangles is enough to be congruent. If they are equal in its sides, it's enough. Why? Because the equality of corresponding sides leads to the equality of corresponding angles. Okay? So let's start to solve some examples. I solved it for you, and let's start to solve it again together. Okay, in this opposite figure, I have triangle RST, okay, congruent to triangle QPO. We are going to play by the letters, okay? And angle S is 90 degrees. Angle S here, the letter which is in the middle is 90 degrees. So the letter which is in the middle, it's also 90 degrees. Okay? Okay. Complete the following. Number one, angle S. Angle S. Congruent to angle what? Angle S congruent to angle P. But before we solve it, let's watch the figures also. I have R, S, T congruent to Q, P, O. That's why I told you to watch your letters first. Okay? So, angle S is 90 degrees, then angle P is also 90 degrees. Okay. Let's start again. Angle S congruent to angle P. Okay, what about angle O? Here angle O, the last one, it's congruent to what? Angle O, it's congruent to angle T. Angle O, it's congruent to angle T. I wrote it for you here. Okay, then we have number 3, angle Q. Okay, angle Q here, the first letter, it's congruent to angle R. Angle Q congruent to angle R. Here it is. Q congruent to angle R. Okay. What about RS? I took here two letters, the first and the middle. RS congruent to QP, the first and the middle. Okay. ST, the middle and the last one. So I will take the middle and the last one. ST congruent to PO. ST congruent to PO. Yes, here it is. ST congruent to PO. Okay. Measure of angle P. Measure of angle P. Here, I need to get the measure of angle P. We wrote it here together. It's 90 degree. It's like S 90 degree. Okay. The last one, PQ. PQ. I will move from the middle to the first one. The middle to the first one. Okay. But I need here to get equal what centimeter? PQ equal what centimeter? PQ like ST. Okay. So, PQ like SR. Okay, and SR here equal 4 centimeter, so PQ also is 4 centimeter. Okay, let's take another example. Okay, in this opposite figures, I have here two triangles. The first one, triangle NOM, congruent to triangle XYZ. Again, NOM, congruent to XYZ. And here we have ZX equal 5 centimeter. ZX. So ZX here, the last one to the first one, or the first one to the last one, is 5 centimeters. So also MN, the last one to the first one, is 5 centimeter. MN equal 5 centimeter. I will write it for you here. Okay. Then let's start to complete our example. XY congruent to here, XY, the first and the middle, congruent to the first and the middle, NO. Here it is. Number 2, angle O. Here we have angle O, the one which is in the middle here. It's like angle here, Y. Angle O congruent to angle Y. NM, okay, NM, the first and the last one, okay, it's congruent to XY, the first and the last, the first and the last, okay. So I have here angle Z congruent to angle what? The last angle here, angle Z congruent to angle M, the last one here. Okay, then the next one, I have measure of angle M. I need to get the measure. I don't have here the angles, the measure of the angle. Okay, so measure of angle M, of course, it will be like measure of angle Z. It's a measure of angle Z. Okay, so the last one, MN. MN. I wrote it here at the beginning of the example. Okay, so MN equal 5 centimeter. MN. Why? Because I have ZX, okay, equal 5 centimeter, and they are equal. Okay, that's why the two triangles are congruent. Don't forget the sign of congruency, please. Okay, the last one here. Okay, in this opposite figure, I have triangle ABC, ABC, okay, congruent to triangle DFE. Okay, and I have angle B 40 degree. Where is angle B? In the middle. Of course, angle F, it will be also 40 degree. I will write it here. Sorry. Again, I have the two triangles ABC congruent to DFE. Okay, so angle B equal 40 degree. Angle B here in the middle, it's like angle F. So it will be also 40 degree. I will write it here, 40 degree. And I will write here angle B equal 40 degree from the given here in our example. And angle A equal 90 degree. Angle A equal 90 degree. Angle E, the first letter here, it will be like angle D. So I will write on the angle A 90 degree, and on angle D I will write also 90 degree. Okay, then let's start. I have here two angles, okay, and one missing angle. Okay, let's start. Angle B. Angle B like angle F. Okay, angle B like angle F. Okay, so angle B congruent to angle F. What about angle E? The last one here. It will be congruent to angle C. The last one here. Here it is. Next one, angle D. Angle D here equal angle, yes, A, the first one or the first letter. Okay, A congruent to D. Okay, angle D congruent to angle E. What about BC? BC congruent to what? Here two letters. Start from B and end with C. BC. It's congruent to FE, the middle and the last one. Okay, so BC congruent to FE. The next one, CA. CA, the last letter and the first one. It's like also ED. Okay, so it's congruent to ED. What about angle E? I wrote for you here the final answer, but how can I get the missing angle? Okay, I have two angles here, 40 and 90, okay, in this triangle or this triangle. Okay, if you want to get the missing angle, we are going to add the two angles together. Okay, 40 plus 90, 40 degree plus 90 degree. Okay, so it will be 130 degree. Then I will subtract it from the total of the angles or the interior angles. Okay, do you remember the interior angles? The sum of the measures of interior angles equal 180. So I will subtract it from 180 to get the missing angle or to get the third one. It will be 50 degree. Okay, so the last one is 50 degree or the missing angle. Okay, I add the two angles together, then subtract it from the 180. Okay, so measure of angle E, I don't know it. Okay, I add the two angles together. Here, 40 plus 90, it will be 130, and then subtract it from the sum of interior angle, the 180. Okay, minus 130, it will be 50 degree. Then the last one, DF. DF equal what? Look at the DF. The first and the second, it will be what centimeter? So DF like AB, and AB here equal 2 centimeter. Okay, DF like AB, and AB equal 2 centimeters, so the result will be 2 centimeter. Okay, let's start to take the second lesson here, the symmetrical figures and lines of symmetry. Okay, in the following table shows the number of lines of symmetry for some geometrical figures. Okay, so I have here the figures, okay, and here the number of symmetry, the number of lines of symmetry, okay, and here also the figures and the number of line of symmetry. Okay, let's start. Number one, parallelogram. The parallelogram has how many lines of symmetry? Sorry, 0. It will be 0. The parallelogram has 0 lines of symmetry. Okay, we can't get from the line of symmetry of parallelogram two congruent polygons, okay, or two equal parts. The number two, sorry, the trapezium. The trapezium also has 0 lines of symmetry. The trapezium has 0 lines of symmetry. Okay, if it will be trapezium only without isosceles or scalene, we can determine as scalene trapezium. So it's 0 lines of symmetry. Number 3 here, I have scalene triangle. Scalene triangle also has 0 lines of symmetry. So parallelogram, trapezium, scalene triangle, okay, 0 lines of symmetry. We consider that as a scalene trapezium. Okay, Let's start by the second figure. The second figure is isosceles triangle. Isosceles triangle, we can make only line here, okay? So we can't make a line like that, and we can't take a line like that, because the isosceles triangle has only two sides are equal, okay? So it has only one line of symmetry, okay? The next figure is the isosceles trapezium also, okay? Isosceles trapezium also has one line of symmetry. So I have isosceles triangle, isosceles trapezium, one line of symmetry, okay? The next figure is the equilateral triangle. The equilateral triangle, because all sides are equal, here I will write it for you, all sides are equal, okay, and it has only three sides, okay, so it has three lines of symmetry. We can make a line like that, and we can make a line like that, and the last one like that, okay. So again, I have parallelogram, trapezium, scalene triangle, 0 lines of symmetry, but isosceles triangle, isosceles trapezium, only one. What about the equilateral triangle? 3 lines of symmetry, okay? The second one is the rhombus, okay? The rhombus has 2 lines of symmetry. We can make a line here like that or like that only. So it has 2 lines of symmetry, okay? If you did the parts like that, it will get 2 congruent parts. And what about the rectangle? The rectangle also has 2 lines of symmetry, okay? So rhombus and rectangle, the 2 figures which started by letter R, 2 R's only, so they have 2 lines of symmetry. What about square? Okay, the square has 4 lines of symmetry. We can make a line like that from the 2 vertex here, or like that, or from the middle here, or the last one from here. It's 1, 2, 3, 4, okay? 1, 2, 3, 4. 4 lines of symmetry, okay? And I leave this part for you, okay? I will leave it here to explain for you again, or make a draft for you to let you study quickly about the lines of symmetry, okay? I left this part for you. I have here a regular hexagon. The regular hexagon has 6 lines of symmetry, okay? It's 1, 2, 3, 4, 5, 6, okay? I'm not going to write here because this is the line number 1. So it has 6 lines of symmetry, okay? And the regular pentagon has 5 lines of symmetry, okay? 5 lines of symmetry, okay? The pentagon already has 5 sides, so it also has 5 lines of symmetry. I will start by here, number 1, 2, 3, 4, 5. Yes, I can't write here. This is line number 1, okay? So again, rhombus, rectangle, 2, okay? Square, 4, regular hexagon, 6, and regular pentagon, 5. What about the square? Infinite number, very large number. We can count it, okay? Infinite number of lines of symmetry. Okay, I left this part here for you to just show you something very easy. If you have the figure start by letter I, isosceles triangle, isosceles trapezium, okay, start by letter R, so it has only one line of symmetry. What about the rectangle and rhombus? Okay, this is 2R here, so it has 2 lines of symmetry. Okay, what about the equilateral triangle. Start by letter E. I have 3 dashes here, so it's 3 lines of symmetry. Okay, but Mr. Square here, Mr. Square, because it has 4 sides are equal, so it has 4 lines of symmetry. Already the hexagon has 6 sides, so it has 6 lines of symmetry, sorry. And the pentagon has 5 lines of symmetry. What about the parallelogram? Okay, parallelogram, scalene, triangle, and trapezium or scalene trapezium. I told you before. Okay, so this 3 figures has 0 line of symmetry. Okay, but last, the circle, it's a very large number or infinite number. Okay, let's start to solve some examples about the lines of symmetry. Number 1, complete letter A. Okay, I have here the isosceles triangle. Start by letter I, has 1 line of symmetry. What about the equilateral triangle? Equilateral triangle, I told you about letter E. Change it into capital and count the dashes. So it has 3 lines of symmetry. Okay, the 3 sides are equal. Okay, letter C, the isosceles trapezium, also start by letter I here, so it's has only 1 line of symmetry. Okay, what about the square? Mr. Square has 4 lines of symmetry. Okay, rectangle, here start by letter R. I have only rectangle, and rhombus, so has 2 lines of symmetry. Okay, letter F, the circle. The circle has infinite line of symmetry, very large number. Okay, rhombus, letter G, rhombus, again R, has 2 lines of symmetry. Well, letter H, this figure. What's this figure called? I'm going to count the sides. 1, 2, 3, 4, 5. Okay, so it's 5 sides, so it is a regular pentagon, has 5 lines of symmetry. Okay, 5 lines of symmetry. Then we have here in letter I, the regular hexagon has 6 sides, so it's 6 lines of symmetry. Okay, I will make here an arrow like that because I will explain it for you later after we finish this part. Okay, K, the scalene. I told you scalene triangle has 0 lines of symmetry. Scalene triangle, all sides are different. We can't make a line of symmetry, so it has 0 lines of symmetry. The parallelogram also has 0 lines of symmetry. And the last one, the trapezium, okay, we consider it as a scalene, so it has 0 lines of symmetry. Okay, so in number A, if we have a diagonal here of the rectangle, this is a rectangle. Okay, I will make it for you quickly. If I have a rectangle like that, a diagonal of a rectangle, okay, do you remember the diagonal of the rectangle? Yes, this is the diagonals of the rectangle. They are equal. They are not perpendicular, but they are bisect each other. Okay, a diagonal of rectangle, divided it into 2 congruent triangle. Okay, if I have a diagonal like that, okay, I have 2 congruent triangle. Here is the first one, and here is the second one. Okay, it divided it into 2 congruent triangle. I will make another one and draw only one diagonal. Yes, it will be congruent. This is triangle number 1 and this is triangle number 2. The diagonal of a rectangle, divided it into 2 congruent triangles. Okay, they are congruent, but it's not a line of symmetry. This is not a line of symmetry. This is not a line of symmetry. Okay, so there is a big difference between a diagonal and a line of symmetry. Again, so here in letter J, it's very important. The diagonal of a rectangle divides it into two congruent triangles. I have two congruent triangles, but it's not a line of symmetry of the rectangle. Okay, I hope it will be clear for you now, the two lessons, the congruency and the line of symmetry. And thank you for watching me, and see you next time.